This is from chapter 12 in math analysis on limits. And this is the basic definition of a limit. The limit as x approaches c of f of x equals L. Now, limit's kind of an abstract term. Let's try to make it a little more concrete. The c here, that is the x approaching c, is a number. That's our input. And L is the output. See, we normally think of this as xy. C represents x, and the output is capital L here, which stands for the limit. The x approaches c. C is going to be a number. The arrow means approaches. Means that it's standing off afar, and they're predicting on the path, which is called f of x, what L is when you get to c. Now basically that's saying what is y when x is c. An instance could be a bridge that could be out on a road over a river. And because of the distance from the bridge at night, as you approach, your assumption is, as I approach the bridge, there's going to be a bridge there. But because of violent weather or storms, the bridge is gone. So we could say as we approach, that's what the arrow means. We're off in the distance. We predict there's going to be a bridge there, or there's going to be a limit there. When we get there, then that may be another thing. Now you'll notice that this is x approaches c, it's not x equals c. At the exact point, that's x equals c. Make a more concrete example. Let's use a simple one. Here the limit of 3x minus 5 as x approaches 2. And we just substitute the 2 in here. That's what this says. Substitute for x, and that gives us 6 minus 5 is 1. Well, let's look at the example here. We have the graph of 3x minus 5. You go down 5 on the y-intercept, up 3, over 1, and draw your line. When you plug the 2 in, you find out the 1 is the output, which means it's this point right here. So from the left and the right, as we approach this, let's approach it from the left. Here we come up. As we approach, x is 2, then it looks like y is 1. That's what our work up here above shows us. As a broad outline, we see three possibilities. This number 2 here could be no positive or negative sign as an exponent. It could have a negative sign in the exponent, or it could have a positive. To the negative means from the left side. Positive means from the positive side, or the right side. It's approaching this number c. We'll expand on that as we go. Now here's an example of a piecewise define. This means y equals 2. Now y equals 2 at wherever x is not 3, which means everywhere. Exactly at 3, y is 0, and we have a picture here of that. And now here is a picture of the top one. Y equals 2. That's a horizontal line. At everywhere but where x does not equal 3. So let's say it this way. When it says x does not equal 3, that's actually much larger number of x's. All of these over here, all of these over here, with one exception. X equals 3. So the exception, x equals 3, is the small case. Again, this might illustrate the concept of a bridge being out, a discontinuity in this line y equals 2. From the left, it looks as you approach that your limit is 2. From the right, as you approach, it looks like your limit is 2, and your limit is 2. as long as it's not at 3. So once again, similar ideas. You park your car in the parking lot, and you expect it to be there in the same spot when you come out after school. Well, it's gone. So you were expecting as you approached the car that it would be there. Your friends moved it. They may have punked you. When you're substituting in these numbers into the equation, you have 3 possible outcomes. The first is called polynomial. And polynomial limits means a polynomial is a continuous flowing graph, has no holes in it, passes the vertical line test. And it always results when you put a x in with a number coming out, normal number. 2 other possible outputs is rational functions, that is, functions that have x in the denominator. Most of the time these graph has hyperbolas. You may want to check your parent functions on that. And what could result when you plug the numbers in is you could get 0 over 0. In fact, this happens a lot. And the good news about that is that means that the problem is reducible. The fraction is reducible. And that as the fraction reduces, we want to do that by 2 methods. We'll talk about those. The second scenario is, what if I plug in the x and I get 1 over 0 or 10 over 0 or 100 over 0? What's that mean? That means that the point is undefined at that point. It could be a vertical asymptote. It may be a hole in the graph, yet to be determined. So let's just do a problem. Now ignore this graph on the right until a little bit later. Notice that as x approaches 4, well, again, all this is just direct substitution. This is inputting. You get 16. Nothing unusual about that. What about the limit as x approaches 3 of 5? Well, y equals 5 is just a nice horizontal line here at y is 5. And so at 3, the output's 5. Just like at 0, it's 5. Just like at 20, it's 5. It's the constant 5. So the limit is 5. Limit is a y direction statement. It's an output. So here's the point 35, and let's go on to another type of direct substitution. What is the limit as x approaches 0 of cosine of x? Well, of course, we plug in 0 for cosine of x. And down below here, you'll notice I have a diagram of a cosine wave. Well, what's happening at x is 1? Well, here it is right here. It looks like from the left side it's 1, and from the right side it's 1. Solution's 1. May help to have this diagram in front of you to do the next one. What is the limit as x approaches 3 pi over 2? Well, that's down here, 270, 3 pi over 2. So we plug it in there, and we can see that the output is 0. So that is the limit. That is the y constraint at that point. Can't go any higher, can't go any lower. It has to be right there. Now, these lines are the path that we're trying to follow. So here's that point, 3 pi over 2, 0. Okay, here's another one. This is a polynomial. Plug in the 3, you get a 10. No big mystery to that one. Then you plug a 3 into, looks like the same equation, but with one addition. It has a denominator, x minus 1. So when you plug in 3 there, you get just like you did on the other side here, you get a 10 over 2, which is 5. So next we move on to x approaches pi as a sine of x. Here's a graph of the sine of x. When x is pi, we're right there. That means the y value is 0. Indeterminate means it is irreducible by factoring, or it is reducible by factoring. So as it turns out, here's a problem where I would know what that graph is. When I plug in my 1, substituting, I get 0 over 0. Well, that's good news and bad news. The good news is you can reduce this. The bad news is you can reduce this. So we're going to do grouping by 2's. Take the first group as x squared out. We get x minus 1. In the second group, x minus 1, we take a 1 out, and these two outside the parentheses become x squared plus 1 times the common parentheses, which is x minus 1. Now you'll notice here that we got a great thing occurring. We have x minus 1 and x minus 1, which just cancels. We just simplified this problem tremendously by factoring it. So the x minus 1 cancels. That leaves me x squared plus 1. Now I go back to the x equals 1, which gave me 0 over 0 here. And I just plug it in again for x. I go right back where I was, and I get 1 plus 1 is 2. This radical x over the square root of x plus 1 minus 1, when you plug in your 0, it gives you 0 over 0. Well, that means it's reducible, but we're going to have to find out how to reduce it. So for that, I wanted to show you this first line here comes from this, the square root of x plus 1 minus 1. We take it times sort of its pair. And this is the square root of x plus 1 plus 1. The only difference here, minus 1 and plus 1. Now, that's not the problem. That's kind of a side issue. So now we're going to plug that into the problem. Now you'll notice here's the original denominator. Here's mine. The one above it, that's mine. So when you collect your terms and multiply this out, you come up with over x, and your x's cancel. See, that's usually what 0 over 0 indicates, is you're going to reduce the fraction, possibly completely reduce it and put it away. So now I come back and I plug in the 0 and I get 2. So this is the way to reduce by radicals in kind of a combination. It isn't conjugate pairs, but it's like it. And then I want to emphasize again the left and right hand behavior. When this little negative sign is in the exponent on this letter, the number here, or it's positive on it, that means from the right side, and this means from the left side. And that brings us to the absolute value of x over x, which with plugging in 0 gives you 0 over 0. Now what we want to do is split the absolute value of x into two separate statements. One is negative x over x, and the other is positive x over x. Well, those both give you either negative 1 or positive 1, one way or another. So you'll notice down here, y equals negative 1 is this one. It reduced nicely. And this one is y equals positive 1. You can see that as you approach from